Hello friends, welcome back to the CSC guy. This is our third lecture of we discussing first chapter in distributed databases. In this lecture, let us start with key distribution design issues in distributed database system. In distributed database system, there are three key distribution design issues. First is data fragmentation, then data replication and data allocation. These issues are crucial in ensuring the efficient and effective management of data in a distributed database system. Data fragmentation. This refers to the process of dividing a large database into smaller fragments, which are then stored on different sites in the distributed system. Fragmentation can be horizontal, vertical, or mixed. Next is data replication. This involves creating multiple copies of data and storing them on different sites in the distributed system. Replication can be used to improve data availability and reduce the risk of data loss. Data allocation. This refers to the process of deciding which data fragments or replicas should be stored on which sites in the distributed system. Data allocation is crucial in ensuring that data is stored in a way that minimizes data transfer and maximizes data availability. Next, let us see what is fragmentation in distributed database design. Fragmentation is a technique used in distributed database design to divide a large database into smaller fragments, which are then stored on different sites in the distributed system. There are three types of fragmentation: horizontal, vertical, and mixed. Horizontal fragmentation. This involves dividing a table into smaller fragments based on rows. Each fragment contains a subset of the rows in the original table. Next is vertical fragmentation. This involves dividing a table into smaller fragments based on columns. Each fragment contains a subset of the columns in the original table. Next is mixed fragmentation. This involves dividing a table into smaller fragments based on both rows and columns. Each fragment contains a subset of the rows and columns in the original table. Here is the example of horizontal fragmentation in Python. See, this code defines a table and a fragmentation function, which divides the table into smaller fragments based on a specified fragment size. The fragments are then printed to the console. Next, let us discuss data allocation in distributed database system. Data allocation is the process of deciding which data fragments or replicas should be stored on which sites in the distributed system. The goal of data allocation is to minimize data transfer and maximize data availability. There are several data allocation strategies, including centralized allocation. This involves storing all data fragments or replicas on a central site. Decentralized allocation. This involves storing data fragments or replicas on multiple sites in the distributed system. Next is hybrid allocation. This involves using a combination of centralized and decentralized allocation strategies. Here is an example of decentralized data allocation in Python. We can see it. This code defines a list of sites and a list of data fragments and a data allocation function which allocates the data fragments to the sites in a decentralized manner. The allocation is then printed to the console. Next, let us discuss some important points. We can let us know what is location transparency. It refers to the availability of a distributed database system to hide the physical location of data from the user, making it appear as if the data is stored at a single location. Next, let us see what are two fundamental design issues in distributed database system. Fundamental design issues. The two fundamental design issues in distributed database system are distribution design and concurrency control. Next, what are the two basic alternatives for placing data in a distributed database system? They are replication, that is storing multiple copies of data, and fragmentation, dividing data into smaller pieces. Next, how does locking work in the context of concurrency control? Locking works by gathering exclusive access to a resource, example a data item, to a transaction, preventing other transactions from accessing the resource until the lock is released. Next, let us see how does timestamping work in the context of concurrency control. Timestamping works by assigning a unique timestamp to each transaction, allowing the system to determine the order in which transactions accessed a resource, and ensuring that transactions are executed in a consistent order. Thank you.